And the next section is pretty much your double angle identities, or your sum and difference. I'm sorry, I haven't got to the double angle yet. And I'm just going to go through and I'll snip these as I go along. Well, let me just do this. I don't want to do that. I want to go here and we'll snip them out. Sum, what's it called again? Sum or difference, because I have to type in the exact words. Sum or difference. Sum or difference. My keyboard is gone. Sum or difference identities. I was hoping to get all of them. Let's see if I can get all of them. There they are. Again, about 3 or 4 buttons. A lot of work. Snip. And we'll take that out. Save. Okay, so let's go to the sum and difference. So you need to write those down in case you haven't. Some of you may have already printed out your identity cheat sheet, which, you know, I doubt very seriously y'all have. But maybe 4 or 5 of y'all have. But there it is. So go ahead and write those down. And we'll start with cosine of 75 degrees. Now, since you're using the cosine, since you're starting off the problem with cosine, you're going to be talking about the cosine identity for 3 and number 4. Now, you could try to do this with subtraction, but I would automatically think of addition. What is 75 as far as addition? And you're thinking in terms of the special angles. Cosine of what? 30 plus what? Okay, now I want you to take what you know about the special angles, meaning draw these special angles out, and then fill in what you need to fill in with cosine of 30 plus cosine of 45. You've got cosine of A plus B, so fill out the right side. And I'll just put it up under it. Cosine of A plus B is equal to cosine of A cosine of B minus sine of A sine of B. So fill it out. In order to fill it out, though, you got to know what you're talking about. You're talking about your special angle of 30 degrees and your special angle of 45 degrees. Special angle of 30 degrees, 1, square root of 3, 2, and special angle of 45 degrees, 1 and 1, square root of 2. So take a minute and put the cosine and the sine in where it's supposed to be and simplify. Now these are actually very simple. Why do people screw them up? One, they don't remember the formula. You don't have to worry about that in here because I'll let you use the cheat sheet. So what's the other reason?
those special triangles?
They don't remember their special angles. Square root of 3 over 2. Square root of 2 over 2. Minus 1 over 2 times square root of 2 over 2. And now you should be able to finish it. Make sure you ask if you got questions, because these are pretty straightforward. So the square root of 3, square root of 2 is square root of what? 6. So the cosine of 75 degrees is the square root of 6 minus square root of 2 over square root of 2. Now, somebody take this cosine of 75 degrees in your calculator. Tell me what you get. Make sure it's in the 2 note. 2588.
Yeah.
All right, now take the square root of 6 minus the square root of 2 and put it over the square root of 2 and tell me what you get.
0.2588.
Have you already done it?
Yeah.
Good job. So you basically, there is a way you can find out the degree, the cosine, the 6 trigonometric functions of several angles based on the special angles. Now I do realize that, because we haven't got to the point to where we can do, you know, the other stuff, law of sines, law of cosines. We haven't got there yet, okay? But what we're doing is using the identities to find different angles based on the special angles. Yes?
That's pretty.
Yeah, I'm sorry. 2. It's supposed to be 2. Yeah. I must have got a square root somewhere. Thank you. It should be the same thing, 2588. Question on that one. Now you'll get 3 or 4 of these on the test also. So I'm going to pick, you know, from the first section, I'll pick 3 or 4 of those. I'll pick 3 or 4 of these. So make sure, and that's what we're going to do today, 3 or 4 of this section. Any questions on this? Square root of 6 minus square root of 2 over 2.
Okay.
Yeah, unless they tell you to do approximate. Remember, this is approximate because you did it on the calculator. And this is what? Exact.
Exact.
All right, now you try the next one. Next one is not the same type of question, but it's one that you might see. And that is cosine of pi over 2 minus x. So that would be cosine of A minus B. So go ahead and do that. Cosine of A minus B. So that'd be cosine of A times cosine of B plus sine of A times sine of B. Basically, you're just plugging in what? Plugging and chugging based on the special angles. Now, you may start this and you may be thinking, well, how are we going to solve for x? We don't know what x is. But basically what you're going to find out is that one of them is going to cancel out. Which one's going to cancel out? Because you're talking about 90 degrees. Think of your unit circle. What?
The left side.
Yep. The left side is going to cancel out. The left side is going to cancel out, and you're left with sine of x. Because the sine of 90 degrees is 1. So your answer is sine of x. Now, why are these identities important? Why is the sign some indifference? From here, in the next couple of sections, these identities are important because, like I said, in Calc 1 and 2, especially Calc 3. In Calc 3, you're going to be taking the derivative and the antiderivative and plugging into the identities. You're also going to be taking the identities and doing stuff with the identities different from any class that you've ever done before, okay? And I'm just telling you that for right now because I can't explain it without actually doing the calculus, so we're not going there. But the actual motion of you taking the angle here and the angle here and plugging and chugging and seeing something cancel out is very valuable in Calc 3. All right? Because that's what's going to happen to a lot of your formulas in Calc 3. They're going to cancel out the first part or the second part, and you're going to be left with just the first part. Okay? Let's try nerd. I'm going to leave this one up to you. See if you can work it out. Y'all settle down. Pendleton, settle down. Sine of 13 pi over 12. Now, before I do anything, and this is just me, I mean, some of y'all invented the unit circle, but I didn't. So I changed that into an angle because I want to see what the angle is. Now, you could break it up into 5 pi over whatever, and you could do that. And that's fine if you want to do that, but I don't do that. So the first thing I'm going to do is change it into a what?
Degree.
I'm going to change it into a degree. So that's going to be 13 pi over 12 multiplied by 180 over pi. Pi's cancel. Okay, I know 6 will go in there 2 times. 6 will go in there 30 times. 2 will go in there. 2 will go 15. Somebody multiply 15 times 13. What do you get? 150 plus...
195.
I'm sorry, what?
195.
195 degrees. All right, so you need to focus on 195 degrees. dang old 45 plus dang old something. Now, I would highly suggest that you draw it out. Why would I ask you to draw out the two triangles on this one? Somebody take what we've learned so far about these two angles that you're going to... What's important about drawing the angles out on this one?
It's not a special triangle. It's not a special triangle.
Both of them are special triangles. Nobody has any idea what I'm talking about? Or y'all just being quiet and introverted? Which one is it?
It's not 2D.
Anybody in Pendleton want to take a stab at it?
Nope, you are.
Miss Crittenden, Easley. Okay. I think, okay. But why do I want you to, why am I making a big deal out of drawing the triangles out on this one? Starts with an S. I. Signs. The signs, because you got two different animals here. You got a, what, 150 degrees and what? 45 degrees. So you got to make sure about your signs. It's not just 45 and 30. 45 and 30 is in the first quadrant. You see what I'm saying? But 45 and 150 is in the first and the what quadrant? Second quadrant. And the second quadrant is going to have a sign difference. So what I would highly suggest you do is draw the 45-degree angle as normal, and then draw the what? The 150, which will be a 30-degree angle in the second quadrant. Now, you can do that, or you can do all students take calculus. I really don't care which one you do. But here's the 30-degree angle. 1 square root of 7. I'm sorry. Square root of 3. I don't know where 7. 7 just entered the brain somewhere. Square root of 3 at 2. And then the 45-degree angle is what? 1, 1, 1, 1, square root of 2. And now, do your sign. So that's going to be sine of A plus B. So that's going to be sine of 13. I'm just going to write sine of A plus B. And that's right here. Sine, cosine, cosine, sine. Sine, cosine, cosine, sine. And that's a plus right there, or minus, plus. And that's going to be what? 150 plus 45. So 150 plus 45. So 150, 45, 45, I'm sorry. 150, 45, 150, 45. 150, 45, 150, 45. All right, go to it. And remember, which one's negative? Which one?
Sine B.
The negative 3. Yep. That's why it's so important. Two things. It's important for you to know what degree you're working with, where you are. And it's important for you to draw the special angles where they are. Because if you don't, or you got to remember what? All students take what? Calculus. You got to do one of those two things. Because all students take calculus will help you there. But it's, to me, that when you're doing this, it's better just to draw them out. Give you about another second or two to finish plugging and chugging. One half square root of 2 over 2 plus square root of 2 over 2, and what? Negative square root of 3 over 2. And work that one out. Now, the first one we did and this one are very, very, very good test questions. Hint, hint, hint.
Sorry.
And that's going to be square root of 2 over what? 4? Plus negative square root of 6 over 4. And then that comes out to be square root of 2 minus square root of 6 over 4. And you feel good about yourself. Who's got a question on that one? You're not going to talk anyway. Pendleton, we good? Are we confused? Or we have no idea what you're talking about?
That one.
No idea.
I have no idea how we got any of this.
Good. Then why didn't you ask a question? How long were you going to wait until you said something? Easily. That makes absolutely, okay, Pendleton, I'm going to tell you something right now. That makes absolutely no sense whatsoever. Easily. I want you to talk easily. Do you have any idea what I'm doing? Are you confused or are you good? Good to go. Which one is it?
I mean, I'm good to go.
Okay, but you're the only person I see. What about, okay, there we go. How about the other two people?
I'm good. I guess I'm good.
Okay. Miss Crittenton.
I got a headache, but I'm good.
Got a headache. Well, you need to lay off the liquor, I tell you. I'm sorry. I think you have a problem. We'll discuss that after class. All right.
All right.
Pendleton, where are you confused? Talk to me. That's what communication is. Not a tit on a bull.
I got lost after we made the triangles.
Okay. You made the triangles. All right. Well,
I know how to get that. I know how you got the 195, and then I know like what you did to get the triangle, but I don't know how you got the numbers in the triangle.
All right. So we need to go back. Now you do realize that speaking out like this, you're going to be like Kanye West on Saturday Night Live. They're probably going to beat you in the hallway. You know that, don't you? Because you're not supposed to talk. Okay. So when you go out in the hallway, the rest of the Pendleton campus students are probably going to beat you up. So make sure you call security before you go out in the hallway, okay? All right, so here we go. Now they're not going to talk now. So I got all the talking out of them that I'm going to get. So he's got a question, and it's a legitimate question. What in the heck do I do after I get the angle? All right, well, you go back to the Unit 1 material. All right, where is your little man? Your little man is right here. Your little man is right here. Okay? Your little person. I don't want to offend anybody. The little person is right here. So that means your angle is here, so that means your opposite is right there, and your adjacent is right there. So if I plug everything in, so here we go. We got A plus B. So the sine of 150 plus, what do we say, 45? 45 is equal to, and we're going to follow this one right here, sine, cosine, cosine, sine. Sine, cosine, cosine, sine. And a plus in the middle. And I'm just going to put this in brackets for you, because I'm just glad you asked the question. Thank you. Because squeaky door gets what? OIL. Pronounce it however you like. I say grease usually. All right, so sine of 150. So we go up to our 150. Here's our 150 right here. This is 150. Because it's in the second quadrant. And I say, okay, sine is equal to Oscar had 1 over what? 1 over 2. So that's 1/2. Oh, I'm sorry. Sine of 150, 45, 150, and 45. Okay, so the sine, that'd be 1 over 2. Okay? Times the cosine of 45. Cosine, Oscar had a hump. 1 over square root of 2. Well, 1 over the square root of 2, I'm going to write that right here. We can't write it like that. Multiply by the square root of 2 over 2, and that's equal to square root of 2 over what? 2. So the square root of 2 over 2. How are we doing at Pendleton? How you feeling? You see where this is coming from?
I understand what you're doing, but how do you get 150 and 45?
150 and 45?
Yeah.
That's equal to this. 150.
Equal to 195. I know it's equal to 195, but why'd you split it into 150 and 45?
Because that's the two special angles.
It's 50.
There's nothing else. I mean, you could say 190 plus 5, but we haven't discussed the side. We haven't discussed those yet. The only angles that you know of right now in your universe is 30, 60, and 45. There's no other angles in your universe right now.
All right. I'm good
So
now.
you have to base everything on what you know. And the special angles are the only thing you know right now. Now, could you have done another? Can somebody do one right quick? Is there any others that equal 195? I'm trying to think. 225, no, 225 minus 45 is 185, isn't it, or 180? So I don't know if there's any other, I don't think there's any other that equal 195. That's the only two. 60 and 135, no, 135 is not a special angle. So you see, some of them work themselves out to be the special angles, and you just have to find them. All right, plus cosine of 150. Well, the cosine, Oscar had a hump. Uh-oh, there's our negative. Negative square root of 3 over 2. And then what's the sine of 45? Sine is Oscar had 1 over square root of 2, which is what? Square root of 2 over 2. All right, who has a question on that? Pendleton? Rest of Pendleton? That never says anything?
Does it matter on what order the 150 and 45's in?
No, it does not. Why? Because what is this right here?
The time.
What is this?
Times.
Multiplication. What is this? What is this right here? 2 plus 3 is the same as 3 plus 2. 3 times 2 is the same as 2 times 3. But what about this guy?
Minus.
You cannot, you got to put it the right way with those. Do you see what I'm saying? Remember, addition and subtract, addition and multiplication. Starts with a C. What is it? Commutative. Don't say commutative. Commutative is something you give each other when you have a disease. Okay? Commutative. Commutative means 2 plus 3 is the same as what? 3 plus 2. And 2 times 3 is the same as 3 times 2. But you can't do that with what? Subtraction and division, you can't do that. So with subtraction and division, you have to put it in the correct way. Everybody with me?
Yep.
Okay, who else has got a question? Since we've got the ice broken here. Oh gosh, I said ice. I threw ice. I threw ice out there. I cannot be a United States Supreme Court Justice because I threw ice. I'm sorry. All right, anybody else got a question? And I've drank beer too, so, and that annihilates y'all too. Anybody that drinks beer can't be a Supreme Court Justice. Anybody got another question? You ready? Ready for the next? Okay, from here, that gives you the square root of 2 over 4 plus what? Well, this gives you negative square root of 6 over 4, and that's going to give you 2 minus square root of 6 over 4, and that is your answer. Question.
Do you always have to keep the answer like that, or could you actually put it in decimal?
Well, that depends on the question, but as with all sciences and all maths, whatever you start with, you end with unless the directions tell you. Okay? So in this case, you can't go with that because they start you with what? 13 pi over 12. So you can't, so the answer will probably be, they'll probably say write exact answers. Exact means what? Radicals. So this is an exact answer. Write that down, exact, if I spelled it right. Somebody take that and punch it through the calculator and give me 4 digits.
Why punch you back there?
Square root of 2 minus square root of 6 over 4. Somebody give me 4 digits.
Negative 0.2588.
2.2588.
Yeah, pretty
What
sure.
is that called? That's not the exact. That's the what?
Approximate.
Approximate. Calculator is approximate. Exact is radical. So it all depends on what the directions ask you. Who else has got a question? Make sure you read the directions. Although sometimes I'm very lenient, but if the directions say write in decimal and round to the nearest hundredth, I'm less lenient. So you need to read the directions. Who else has got a question? All right, now I want y'all to do the tangent of 105. Tangent of 105. I'm going to put it on the board, but y'all can, I think y'all can understand. Tangent of 105. Yay. Tangent of 105. Well, we don't have to find out where we are because we know where we are. We're at 105. So all we have to do now is we have to say, well, I need to break up tangent like we did in the first problem and say 45 and what? Or 30 and what? Or 90, not 90, but what does 105 come out to be? How about 60 plus 45, Hubert? That sounds good, class.
Thank you.
You're welcome. Thank you. Tangent of 60 plus 45. Now the question was, does it matter if I say 45 plus 60? Yes or no?
No.
No, it doesn't. Because plus addition is commutative. The reason I say commutative like that is when I was at Clemson, I had Dr. Ruckel, and he was the guy that played Tetris all the time. And he was there for about 152 years. And he would fuss at you and embarrass you if you said commutative. And, you know, when you get to those level 3 and 4 level mathematics courses, there is no numbers in the math course. Does everybody understand that? You're doing nothing but theory, algebraic, calculus theory, trigonometric theory. You're doing all that behind these things right here. And he said, now what is this? And I said, commutative. Oh, my Lord. He lit into me like white on rice. And he started embarrassing me, and he says, blah, 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 and then it's commutative. And that rings in my head whenever I see that word, commutative. I see Dr. Ruckel. So remember, commutative. It's not commutative. Commutative is a disease. You're welcome, class, for that information. So I'm doing tangent of A plus B is equal to, and we'll go over here. There's only two you can pick from. Tan plus tan over 1 minus tan tan. Tan, 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 tan. Most people would laugh at that, you know, but not this freaking class. No, this freaking class, tit on the bull. Tan, 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 tan. But A and B. Oh my gosh, somebody sneezed. Somebody's going to beat them up. They've already quietened that guy up there, Pendleton. They're not going to let him talk anymore. That's all right. You can send me messages, okay? If you need to send help for anything like that. Nothing. Nothing at all. I think I got 1 or 2 smiles, but that's it.
They smiled?
All right, so tan of 60.
Yeah, square root of 3 over 4.
Well, we're going to get there. Hold on.
Sorry.
That's all right. Just leave.
Okay.
Tan of 45 over 1 minus tan of 60, tan of 45. Okay, now, what is the tan of 60?
Square root of 3 over 1.
Square root of 3 over 1. What is the tan of 45?
1.
I heard somebody say something.
1.
1. 1 minus the tan of 60 is the square root of 3 over 1 times tan of 45 is 1. All right, finish it out.
What did you do at the bottom?
When this thing gets to the right and to the bottom, I can't hardly write with it. And that's supposed to be a plus right here. I'm sorry. So that's going to give us square root of 3 plus 1. Oh, come on. One of these pins, square root of 3 plus 1 over, I went ahead and it was 1 minus square root of 3. Okay, now, finish it. Not finished. Why am I not finished? You got a radical, I feel faint. You got a radical in the denominator. So I've got to multiply by, what's it called? The conjugate. Which will be 1 plus the square root of 3 over 1 plus the square root of 3. Now we need to finish it. So you need to make a note that that's the conjugate. Right, Pendleton? Thank you, Pendleton. Easley, we good?
Yes.
Yep.
Miss Crittenton, we good?
Yes, sir.
See, Miss Pendleton, Miss Crittenton, see, she's free. She don't have anybody that's going to beat her up in the hallway.
True.
But the Pendleton campus, I feel sorry for that guy that talked a while ago. He's going to beat up, all kinds of stuff. So, what is the bottom? That's shortcut number 3. Shortcut number 3 will give us 1 squared minus square root of 3 squared, which is 1 minus 3, which is negative what? Negative 2. And then the top is going to give us 1 squared. This is shortcut number 1. 1 squared plus 2 square root of 3 plus square root of 3 squared is 3, right?
Yes.
And that's going to give us 4 plus 2 square root of 3 over negative 2. And then that's going to give us -2 minus square root of 3. So I've shown you 3 test questions so far. Now I'm going to open up for questions. So let's get to the questions. Who's got them?
I think I'm starting to get the hang of it.
What? You're starting to get the hang of it. Well, I have not succeeded, because my job is to discourage and get y'all to quit. My job is not to teach y'all to where y'all can learn. How about it, Pendleton? Questions?
Can we do another one like this, please?
Sure. Let me see if I can find one. I'll see if I can find one in the homework. How about Easley?
Good.
I'm going to talk to me now. Let me see if I can find one. Because you can't make these up, but let me see if I can find, well, I tell you what, I got one right here, and you have to find the tangent, so let's do that one.
How would you do tangent 15 degrees?
That's not a special angle.
Okay.
Now you could do, well, see, each one of the ones that you do, you have to be able to get that sum from the special angles. So you could do 60, you could do 30, which would be 60 minus 30.
Yeah.
You could do 60, okay, oh, you just saw that now? You just see what I'm talking about? Okay, maybe that's what the ones at Pendleton were. So you can't do 15 because you can't get 15 from 60 and 30. What's 60 and, well, you could do 60 and 45, couldn't you?
Yeah.
Yes. You could do 60 and 45 and get 15.
Oh, minus, yeah. Then,
So I tell you what, let's just do that one. Let's do the tangent of 15 degrees. You did good. Woo. Let's do the tangent. You don't have to come back. I'm just going to give you an A now.
Woo!
That's a joke.
I know.
darn it.
I was really.
All right. Do the tangent of 15 degrees. Tangent of 15 degrees, and I'll just go ahead and tell you, we said it a while ago, is equal to the tangent of what? 60 minus 45. So now you take 60 and 45 and plug it into this one right here. So the good thing about the tangents is, once you pick the one or two, you just have to plug and chug, the sum and difference, once you find them. So what's the tangent? Oscar had a hump of apple. That's going to be square root of 3 over what? 1. So that's going to be here, it's going to be the square root of 3. And down here, it's going to be the square root of 3. Would be, let me try that other stylus. I think this one's kind of messed up. Okay? And then the tangent of 45, okay, this is going to be real hard, is 1. So that's going to be 1 right there, and a 1 plus here, and then times 1. And then, of course, we're going to have square root of 3 minus 1 over 1 plus the square root of 3. And the conjugate?
1 minus square root of 3.
You are gifted and talented. 1 minus square root of 3 over 1 minus square root of 3. And that's going to give us 1 minus 3 on the bottom, which is -2. And on the top, you're going to get the same, just about the same thing. I'm going to rewrite this as 1. No, you can't. You can't because it's subtraction, so it's going to be different. All right, so 1 times the square root of 3 is the square root of 3. Outside is -1. Inside is 3, right? -3. And last is be a positive square root of 3. Somebody check that for me. Make sure I did that right. 1 times the square root of 3, then -1, then minus square root of 9, which is -3, plus the square root of 3. Square root of 3, negative square root of 3 times -1. Okay, so the square root of 3 plus the square root of 3 is 2 times the square root of 3. And what's -1 minus 3? -4. And then -2, and that's going to give me what? Be 2 minus square root of 3. How about that? So now you got 4 in your notebook, because that's a good test question also. How we feel now, Pendleton?
That was correct.
Okay, we had somebody ask to do another one. You want to do another one? Okay. Thank you very much, Pendleton, for your interaction. Did I say something wrong? Did I say something to hurt your feelings or what?
Maybe. I have no idea.
Easily, how are we feeling?
Pretty good, man.
I'm good.
Okay, Ms. Crittenden,
So good.
appreciate y'all answering my question. Well, let's see if it'll take it out. It's going to take out everything. Nope. And give me a second, y'all. All right. So here's another type question you may see, but it's kind of got a test question in it. A, B, C, and D. And C and D is really ridiculous, but we'll do A. And it says that cosine of A, sine of A plus B, and then the tangent of A minus B, and then I'm just going to put quadrant right here because it's a stupid question. We'll talk to it. We're not going to write it. And they give you the cosine of A is equal to 3/5, and they give you the sine of B is equal to 5/13. Okay, I want you to write all that down and then just say given. And put given, because that's what they'll give you. Oh, I also got to put the restrictions over here. 90 degrees, the first quadrant. Both of these are in the first quadrant, okay? I'm just going to make it simple. First quadrant. They'll give it to you in the homework and say A is between 0 and pi/2, and B is between 0 and what? Pi/2. That's 90 degrees. That's in the first quadrant. Everybody with me? Gotcha. And then they ask you in C or D, what quadrant are you in? That's what blows my mind. They give you this. They give you this right. I'll just write it down for you. A is between 0 and pi/2. And then B is between 0 and pi/2. And then over here, they ask you in C and D, what quadrant is it in? It's in quadrant 4. C and D is kind of redundant, so that's why I'm not really worried about C and D. I just want you to be able to do A and B. Well, the first thing you're going to say is, wait a minute. They're asking for the tan, and we don't even have the tan. Pythagorean identity, Pythagorean theorem. I want you to find the tan of both A and B. See, that's the question. Whether you know to find the tan of A and the tan of B, given the information, the cosine and the sine of B. So that's what they're asking you to do. Find the tan of A and B before you even get started. So how many different ways can you do it? Well, you can do it several different ways. You can do it by the Pythagorean identities, or you can do it by the Pythagorean what? Theorem. Most people use the theorem because it's easier, and I don't care which one you use. So go ahead and find it. And some of you may need a little push. So I'm going to do A. Let's see, the cosine of A is equal to, Oscar had A hunk, and then that's equal to 3 over what? 5. So that means we got a triangle with an adjacent of what? 3, Hubert, and a hypotenuse of what? So therefore, 5 squared minus 3 squared, square root is equal to, we'll put y here, okay? So square root of 5 squared minus 3 squared is equal to y. And 5 squared is 20 what? 25 minus 9 is 16. The square root of 16 is what? 4. So y is equal to 4. Now that's with the angle A, okay? Now let's do angle B. I'm going to let you get B. So sine of B is equal to Oscar had, and that's equal to 5 over 13. I'm going to let y'all do the rest on the Pythagorean just to make sure y'all remember the Pythagorean theorem. If you don't, then just mark that up as being a disappointment.
Okay. The real disappointment is if you don't know the quadratic.
Yeah.
Formula.
Don't sing it. Please don't sing it. Actually, you need to know how to do completing the square. And they don't teach that in high school because they have to teach. They would rather just, give you to the calculator goddess or gods and let you play on the calculator for the rest of the semester using the quadratic formula. And then when you get to college, you can't do completing the square. But I'm not going to. It's kind of like throwing the kid out in the backyard. You got a fence, throw in the backyard so you don't have to watch them. Kind of the same concept. Teach them the quadratic formula so you won't have to teach them completing the square. Therefore, they can do everything on the calculator. But the calculator, the only reason you have the quadratic formula is to do quadratics with decimals. The rest of them you're supposed to do with completing the square. Don't even get me started. So you have a triangle, and you have 13, and then the opposite is 5. So this, you're going to have 169 minus 25, which is 144, and the square root of 144 is 12. So x is equal to 12. So if I want the tangent, so take my handy dandy eraser. If I want the tangent of A, then I'm going to go, okay, tangent, Oscar had a hunk of apple, that's 4 over 3. Write that down, highlight it, because that's the part that you're going to use. This part you're going to use. And this part you're going to use. And one more, and that's the tangent of B. Tangent of B is equal to, Oscar had a hunk, 5 over 12. And that is the last part. Now you have everything you need to find whatever I give you. So you have this, you have this, you have this, and then you have that, and now you've got everything you need to find those two things. So go ahead and find them. you're going to be using this one, and you're going to be using this. And I'm going to take my handy dandy answers, and I'm just going to put them over here. Cosine of A is equal to 3/5. Sine of B is equal to 5/13. Tangent of A is equal to 4/3. And the tangent of B is equal to 5/12. Okay, how are we doing, Pendleton? Got questions so far?
Not yet.
Okay, not yet? They've done tranquilized that other guy. They've tranquilized him. He's not even in the picture anymore. Easley, how we doing?
Good.
Good. Yeah.
Miss Crittenden, you quit yet?
No, I'm good.
Dang it. Oh well, there's always the next unit. Somebody check on that guy, make sure he's not drooling over himself after y'all tranquilized him.
Fine.
Yeah, you can shrink it.
I don't want to shrink it, I want to start over with a clean slate. Like I said, it's been a whole lot better if we got trained on this. But I'm still learning since I've trained myself. All right, so here we go. I think we wanted the sine of A plus B. So that's going to be the sine of A. What is the sine of A? Well, let's just write it out. Sine of A plus B is equal to sine cosine and what? Cosine sine. Cosine sine, and that's going to be a plus. And the sine, we're going to do the sine of A, AB, and AB. AB and AB. So now we just plug and chug. The sine of A. We didn't get the sine of A. I thought we had the sine of A.
We did, but you erased the triangle. It's 12.
Okay, what is our
It's
okay.
12.
Sine of A is what?
The 30 is 12, so it's 12 over.
12 over 13?
Sure.
Y'all check me. I must have done, and I need the cosine of B. I forgot to get that one too. Or did I not write it down?
You didn't.
What's the cosine of B?
It was the 3, 4, 5.
I'm sorry, what?
The 3, 4, 5 triangle.
Well, that would be the sine of A. That's 12 over 13. And the sine of B, the sine of A would be the 4, 5, or whatever.
Sorry.
That's all right. I'm glad you reminded me. I had it written, I just didn't write them all down. Okay, what is the sine of A? What did it come out to be? 4 over 5? Somebody help me out.
Yeah.
All right, everybody check right quick. Well, Easley, Oconee, and Anderson, check and see if that's right because Pendleton won't tell me. So check and make sure I wrote down everything, copied everything from the previous screen. So what is the sine of A? 4/5. What is the cosine of B? 12/13 plus the cosine of A, 3/5. Sine of B is what? 5/13. So I got to have a common denominator. I'm just going to put everything over 5 times 13. I'm not worried about what it is right now. So that gives me, okay, 5 will go into 13. Okay, I'm sorry, that's later. Okay, 4 times 12, or 4 times 12 is what, 48?
Yes.
Plus 3 times 5 is 15. thank you. 63 over 65 is your answer for the sine of A plus B. Yep. All right, now you do the tangent of A, what, and tangent of A plus B? Okay, do the tangent of A plus B. I'll give you all a minute to work on that. Tan of A plus B. Check the time before y'all start to self-combust. Okay, we got plenty of time to finish tangent of A plus B. I don't want Pendleton to get the walls all messy when it's look up. So, tan of A plus B is equal to tan of A plus tan of B, over 1 minus tan of A, tan of B. Now the tan of A is 4/3 plus 5/12 over, really, over I'm about ready to.
McDonald's.
Over 11, I'm not sure.
Well, I can't even write down the problem. 1 minus 4/3 times 5/12, and that's going to give us, well, the top's going to give us, well, 12. Let's just go ahead and get a common denominator. This is going to be 4 16/12.
Yep.
16/12 plus 5/12 is 21/12 over, and then this is going to be 4 times 5. I'm just going to rewrite 1 minus 20 over, I know you can reduce it, but 36, and that's going to be what, 10 over 18, which is 5 over what, 9? Y'all check me. 5/9? Yes or no?
Yeah, it's 5 minutes.
5/9. Thank you, one person. 5/9. And that's going to be 9/9 minus 5/9 is 4/9. So 21 over 12 times what? 9 over 4. Y'all check me. And that's going to be 3. And that's going to be 4. And I'm looking to see if anything else cancels.
Nope.
So that would be 21 is what? 63 over 16?
84.
What?
21 times 4. No.
21 times 3 is 63, isn't it?
63.
Over 16, somebody check me. Let me check my notes. I don't know why I don't use my notes.
That sounds right.
Let's see what I got. Okay, I got something different. I got
that's because-
16. Okay, be quiet now. Be quiet. Don't start saying anything now. Oh, I did A plus B. I did A minus B in my notes. What did it ask for? A plus B or A minus B?
Well, we did A plus B.
I know, but what did I ask for in the original screen?
Originally, you asked for A minus, or tan A minus B.
A minus B. So you do A minus B. A minus B comes out to be, and you can do all of these really if you wanted to. A minus B, do the tangent of A minus B for, extra work. And that's going to be equal to tangent of A minus B is 33 over 56. So you can try that and try these others. Since you've got everything now, you can do all 6 identities with this problem. And that'd be good practice for you along with your homework on 9.2? So you're responsible for 9.1 and 9.2 homework. Are you able to get into it?
Yeah.
Okay. Any questions? Pendleton. Settle down, Pendleton. No questions? Okay. Pendleton, don't beat up on that guy. They're not going to say anything. Easily. Any questions? They done easily got rid of Mr. Swords. He ain't even there anymore.
I actually
Ms.
have a question.
Christensen, you have a question?
Yeah.
Yes, ma'am.
Whenever you did the A plus B.
Hey, hold on, people. Hold on, just wait a minute.
Like
Y'all
when you
go ahead,
crossed out.
Pendleton. I'm just gonna mute y'all, and if you got a question, holler back. Okay, what, Mrs. Crittenden?
Okay, where you crossed out like the 9 and the 12, like how exactly did you do that?
Where
Like
back?
you just where it says like 16 over or 63 over 16, you just simplified like the 9 and the 12.
Okay, right here,
Wait, I can't see
63
it.
over 16.
Yeah, I'm just talking about like how you like before you got that, you had the 20 or 21 over 12 times 9 over 4.
Okay.
Were you just trying to get a common denominator?
How many times will 3 go into 9?
3,
3 times. How many times will 3 go into 12?
4,
Okay, what's 21 times 3?
63. No, I mean I
What's
got
4
that.
times 4?
I got that. I guess I was just asking, like, were you just trying to find a common denominator in order to get that?
It was just.
Or were you just...
You just cancel. No. Here, okay, up here, I had to get a common denominator.
Okay.
Okay, there I had to get a
Yeah.
common denominator.
Because you're adding.
With multiplication, you don't have to. And
You're
division
simplifying.
is nothing but multiplication by the reciprocal. So
Right.
when 21 over 12, this is 21 over 12, divided by, I think I skipped a step, and I think that's where you might be right here. What's 9/9 minus 5/9? 4/9.
4/9.
So I'm going to multiply this by 9/4. And
Okay.
that's multiplication, so you just use cancellation or multiply and reduce.
Gotcha.
Okay?
Cool. Thank you.
All right, y'all ready to work on homework all weekend?
All weekend.
See y'all.
See.
Uh,
Open up.